What if you could take a thick, heavy industrial fuel, the kind of stuff usually seen as a problem, and turn it into one of the cleanest energy sources on the planet? Well, today we're going to dive into some amazing science that's trying to do exactly that, unlocking clean hydrogen from a very, very unlikely source.
So this is the big question, right? Can we really take a low-grade, superabundant fuel and chemically flip it into clean hydrogen? Look, if the answer to this is yes, it's an absolute game changer for clean energy. It's a huge scientific puzzle, for sure, but the potential payoff, it's just enormous.
Now, to really get why this research is so cool, you first have to understand the problem it's trying to solve. And it's a classic dilemma with two very different sides to it.
Okay, so it pretty much boils down to this. On one side, we have tons of this stuff called fuel oil blended stock, or FOBS. It's a heavy, kind of undesirable byproduct from oil refining. And on the other side, we have this massive, growing need for clean hydrogen to power our future. So the million-dollar question is, how do you turn that problem into the solution? This is where the science gets just incredibly clever. Researchers are looking at a very specific chemical process that might just be the key to unlocking all of that clean energy potential. The process is called catalytic pyrolysis. I know, sounds super complex, but think of it like this. It's kind of like pressure cooking, just at way, way higher temperatures, and with absolutely no oxygen. You add a special ingredient, that's the catalyst, which basically guides the whole reaction, as intense heat breaks down the fuel's big, clunky molecules into brand new, much simpler stuff. And the workflow is really a pretty straightforward three-step dance. First, you heat up the fuel oil in a sealed container, a reactor. Second, you introduce that special catalyst to kick off the transformation. And third, you collect everything that comes out. The hope, of course, is that the gas you collect is packed with valuable hydrogen. But, and this is a big but, this entire process, all of it, hinges on that one special ingredient, the catalyst. It's the tiny, unsung hero of this whole chemical story. And for this research, the star of the show is a very specific catalyst. It's nickel, supported on a ceramic material called ceria. The best way to think of it is like a molecular matchmaker. Its job is to create the perfect surface where those large, clumsy molecules in the fuel oil can break apart and rearrange themselves into something way more useful, like simple hydrogen gas. But here's the thing. Not all matchmakers are created equal. The researchers are basically experimenting with different recipes, changing up the amount of nickel they use, trying out 5%, 10%, 15%, even up to 20% to find that Goldilocks formula, the one that's just right for producing the most hydrogen. Now, making these catalysts isn't as simple as just mixing stuff in a bowl. It takes incredible precision. They use a special technique called the impregnation method to make sure the nickel is spread perfectly and evenly across that ceria base. It really shows you the level of craftsmanship that goes into this kind of science. All right, so they've got the fuel figured out, and they've got their catalyst recipes ready to go. So how do the scientists actually put it all to the test? Well, they follow a very clear, very logical four-step plan of attack. The whole project follows this clear roadmap. Phase 1, analyze the fuel, so you know exactly what you're starting with. Phase 2, actually create those different catalyst samples. Phase 3 is the main event, running the big pyrolysis experiment. And then, Phase 4, that's the moment of truth, analyzing all the products to see what they've actually made.
But before the main event, the catalysts get a full checkup. You can think of it like putting our tiny hero under a bunch of super-powered microscopes. Using all these advanced tools, and don't worry about the acronyms, the scientists check everything from its internal crystal structure and its microscopic shape to its exact chemical makeup. They want to make sure it's absolutely perfect for the job.
So, after all this careful prep and all these meticulous experiments, what does a win actually look like? How are they going to measure success? The project has three big, clear goals. First, they need to successfully create all the catalysts. Second, they need to fully understand how they behave during the reaction. But the ultimate prize, the real trophy, is finding that perfect recipe, the one catalyst and the right conditions that produce the absolute maximum amount of hydrogen. To get that final answer, they feed the gas they've made into a machine called a gas chromatographer. This device is basically the final judge and jury. It precisely measures what's in the gas and tells them exactly how much pure hydrogen they managed to create. And ultimately, that's what it all comes down to. The fuel analysis, the different catalyst recipes, the high-tech checkups, it all boils down to this one single goal. The entire scientific effort is a hunt for maximum H2 yield. Research like this points to a much bigger idea. If science can really turn a so-called dirty industrial byproduct into clean hydrogen energy, it really makes you wonder, what other incredible solutions are just hiding in plain sight, waiting to be unlocked from the things we currently just throw away?